Hey guys, welcome back to Buffers. In this video, we are going to work an example using the Henderson-Hasselbalch equation. Again, disclaimer, this equation is only for buffers. I know it makes things really easy and you want to use it for weak acids and bases, but you can't. Don't. It only works for buffers. So here's our example. Calculate the pH of a buffer solution that is 0.25 HCHO2 and 0.5 nacho. Ka for this equation is 1.8 times 10 to the negative fourth. While it's not necessary, I think it's still good practice to write a balanced chemical equation for this buffer. So HCO2. That's going to be our weak acid. I know that because it starts with H, so that kind of tells me that it's an acid. Reacts with water. That's our acid. Our conjugate base is this, the CHO. If that's our acid, water's acting as a base, so it's going to accept a proton. So now using the Henderson-Hasselbalch equation, we're just going to plug in our values for each of the pieces. I'm going to do it on the next slide just so I have some room to work here. Alright, so pH equals, so the first value is pKa. So remember, pKa is just the negative log of the Ka. So I'm going to write negative log of the Ka value, 1.8 times 10 to the negative 4. We're going to add that to log. So concentration of base over concentration of acid. That's why I think it's helpful to draw this so we know exactly what's the acid and what's the conjugate base, and we can get the right thing into our formula. So the base is the CHO2 minus. So where we get that initial concentration is from that salt right here. So the 0.5 is going to go on the top. And then our acid is going to go on the bottom. So our initial concentration of the acid was 0.25. So from here, the math is pretty basic. The biggest mistake the students make is getting things into the right location. So we're just going to clean this up along the way. So I'm going to take negative log of 1.8 times 10 to the negative fourth. So that's going to give me 3.74. And then I'm going to add that to the log of, I'm just going to clean this up, 0.5 divided by 0.25. So pH equals 3.474. I'm going to type in log 2. So this is 0.30. So adding those two numbers together, we get pH equals 0.04. So a much simpler path to the solution. We don't have to do ice tables. We can use Henderson-Hasselbalch as long as it's a buffer and as long as X's small approximation works. I hope you guys found this helpful.